this is going to be 8.2 graphs of other trigonometric functions. So we graphed the sine and the cosine function extensively, changing the amplitude, changing the period, and vertical and horizontal shifts. So now what we're going to do is we're going to look at the other trigonometric functions. So we're going to start with cosecant and secant. So one of the things to know about this cosecant, if you remember, cosecant of x using one of the identities is just a reciprocal of sine. So when you kind of think about the sine function, remember that the sine goes through 0 at many different times. So remember that when sine is 0, you're going to have this undefined term. Remember, 0 on the bottom is not okay. So whenever you have a 0 on the bottom part, you're going to have an undefined, which means that this function itself is also going to be undefined when sine of x is equal to 0. Okay, and actually what you're going to have is something called a vertical asymptote. Okay, and a vertical asymptote, all it is just basically a line, a vertical line that the graph gets close to, but it's never going to touch. So the graph maybe it's going to go really, really close to it, but it's never going to touch it. Okay, so this is what a vertical asymptote really looks like. Okay, and later on we'll find the equations of these asymptotes. Okay. So let's first start off by graphing the cosine of x. So the first thing that I like to do when I'm graphing the cosecant. So the first thing that I like to do to graph the cosecant is graph the sine curve. Okay, so basically let's graph sine first. Graph y equals sine of x. So that's what we're going to do. So the sine curve, remember, starts at 0. Then you have pi over 2, pi, 3 pi over 2, and then 2 pi. So the the sine curve has an amplitude of 1. We know that it starts at 0, and then 1, 0, negative 1, 0. So it kind of looks like this. Okay, and then you can keep going if you want. But basically what you got to look at for what the cosecant graph is going to look like is you first want to look at where exactly is there going to be these vertical asymptotes. And the vertical asymptotes are going to appear wherever the sine curve is at. So the sine curve, wherever the sine is 0. So see, this sine curve is 0 at multiple points. So if the first point is at 0. See, here this is 0. There's going to be a vertical asymptote there. So this at pi is also 0, so you're going to have a vertical asymptote there, so it's undefined. And then at 2 pi is also going to be 0, so it's going to be undefined there as well. Okay, and now remember that when we're thinking about reciprocals, we're just kind of flipping the sine curve. So you can kind of look at the identity. We're flipping the entire bumps. So here you see you have this little bump. You're going to flip this guy upside down. So kind of think about it as a parabola. And we're going to do the same thing with the other ones. We're just going to flip them. Flip, flip, and then flip. So basically, the cosecant curve is basically everything except the sine curve. So let me draw a really nice graph of it. So you're going to have 0. You're going to have pi over 2, pi, 3 pi over 2, and then 2 pi. So your asymptotes are going to start at 0. Then it's going to go to pi. And then it's going to go to 2 pi. Okay? So you're going to have these vertical asymptotes. And then you're going to have a 1. Remember, those were the amplitudes. But now here we don't have an amplitude anymore. At these points, wherever you didn't have an asymptote, you're just going to have these vertical parabolas. Okay? So they're pointing up, and they're also oscillating, pointing down. And the thing about these parabolas is that these guys are not, they're not crossing the asymptotes. So they're getting really, really close to it, but they're not touching it. Okay, so basically this graph is going to go really, really close to this asymptote, but it's never going to touch it. It's just going to get close to it. So this is basically the cosecant curve. So this is the graph of the cosecant curve. Right now, we're not going to talk about the domain and the range yet. We're going to talk about it later. But right now, you can kind of see what exactly the cosecant curve is basically going to look like. So one of the things that you want to start off with is start off by graphing the sine function, then flip everything, locate wherever it's 0. That's where the asymptotes are going to be at, and then just flip the sine curve. And this is going to be basically the cosecant curve. Now we're going to do the same thing with the secant curve. Now the secant curve, remember that the secant of x is equal to 1 over the cosine of x. And you remember that you're going to have vertical asymptotes where the cosine is equal to 0. You will have vertical asymptotes. So I'm going to write VA for vertical asymptotes. Okay, so what you're going to do is let's start off by graphing the cosine curve. Okay, so the cosine curve, remember it starts at 0, then pi over 2, then pi, 3 pi over 2, and then 2 pi. And then remember with the cosine, you are always going to start at 1. Okay, so 1, 0, negative 1, 0, 1. So when you graph something like this, it's going to look kind of like this. Okay, if I can continue on. Now remember, we want the secant of x. So we're going to do kind of the same thing, but instead, we're going to look at the vertical asymptotes of cosine, which in this case are going to be opposites. Now at pi over 2, it's 0, so we're going to write an asymptote there. Another asymptote at 3 pi over 2. And then there's probably another asymptote over here. And then we're just going to flip the phases. Okay, so all of these crests, we're just going to flip them over. So the secant curve, if I were to get rid of the reference curve of the cosine, is going to look something like this: pi over 2, pi, 3 pi over 2, and then 2 pi. So you have vertical asymptotes starting at pi over 2, and then at 3 pi over 2. And then you have these at 1 and then negative 1. You're going to have these parabolas, these parabolic shapes, okay, that are getting closer and closer to the vertical asymptotes, but they're never going to touch it. So you can kind of look, if you want to look at the secant and the cosecant, they're kind of like pi over 2 units over. So if I shift everything up by pi over 2 units, you basically have the other graph. Okay, so this is basically the secant. Okay, this will be the secant. Okay, so now that you know the cosecant and the secant, I'm going to give you a couple of directions on how to graph them. So here are the directions. We're going to start off by sketching either the sine or the cosine curve, depending on which one you get. So if you get secant, you're going to graph cosine. If you get cosecant, you're going to graph the sine. You're going to graph the curves as normally, okay, leaving the vertical shift out. Okay, so you're going to not include the vertical shift, okay, if it's the D part. Keep in mind where it crosses the x-axis, that's where you'll find the asymptotes. Flip the graph and then do the vertical shift at the very end. Okay, so this is basically what we're going to do in our next video. So here are the directions, and we'll do an example in the next video.